In this video, we're going to be going over the differences between the VSPER model and the quantum mechanic model of the sulfur tetrafluoride molecule. As you can see, there is a central atom of sulfur with 4 surrounding fluorine atoms in this SF4 structure. The molecular shape is seesaw, while the geometric arrangement is trigonal bipyramidal. There are 10 electrons and 5 charge clouds on this structure, but in this model it's missing a lone pair because it is the ideal model. The bonds are straight, as you can see, because this is the ideal model and there's no bending due to lone pairs. The SCF energy level is negative 794.899, and we're going to start with the bond angles. So this first bond angle is 180 degrees exactly. The second one is 120 degrees exactly. The third is 90 degrees exactly. And this is an ideal trigonal bipyramidal arrangement bond angle. We're next going to be looking at the dipole moment. It's facing the most electronegative atom in this structure, which in this case is fluorine. This is due to the most electronegative faces. And it is shorter because the bonds on the top are straight, therefore they cancel out. We're going to look at the quantum mechanics structure now. As you can see, this is a bit less ideal. As you can see, the bonds are bent, not as straight. Therefore, you know that it's going to be decreased in the angles due to the lack of lone pairs, or due to the lone pairs that should be here in this figure. So the bond angles, first the SCF energy is negative 794.928, and this is a decrease. It's not significant, but it is a minor decrease. And then we're going to look at the bond angles on this and see how it's changed. So this first one is 106.394 compared to the 120. This next one is 164 degrees compared to the 180. And this last one is 85 degrees compared to the 90 degrees on the VSPER model. And this is all decreased due to the lone pairs that are pushing down on the bonds. Lastly, the dipole moment. It's going to be larger due to the addition of vectors. We are adding the vectors because in the VSPER model, you were able to cancel out, but in these, they're bent, so you have to add each vector together, which creates a longer dipole moment. The whole purpose of the geometry optimization and the quantum mechanics is to find which point at which the energy is the least, as where the minimum energy is, which we found here in this model through quantum mechanics. And for the SCF energy, you want the lowest energy, and more stable molecules have a lower energy, which is why we like the SCF energy of the quantum mechanics better than the VSPER model.